Hello math learners! In this video, we are going to continue discussing about polygons. So let's begin. These are the parts of a polygon. First, vertex. In this polygon, we have 5 vertices. Vertex A, vertex B, vertex C, vertex D, and vertex B. The next part is called angles. In this polygon, there are 5 angles. Angle C, angle B, angle E, angle A, and angle B. Next, we have sides. Since this polygon has 5 vertices, 5 angles, that also means this polygon has 5 sides. 1, 2, 3, 4, and 5. And the last part of a polygon is called diagonal. Okay, a diagonal is a line segment formed by connecting 2 vertices that are not adjacent. So for example, vertex B and vertex E, if we are going to connect this one using a line segment, this line segment is called diagonal. Now, let's name polygons. How do we name polygons? Let's say for example, we have here a given figure. What is the name of this polygon? We can name the polygon based on its vertices. We can use the vertices A, B, C, D, and E. So let's say the name of the polygon is polygon A, B, C, D, E. You can also name it as polygon B, C, D, E, A, or polygon C, D, E, A, B, or polygon E, A, B, C, D. Next are the vertices. How do we name the vertices? Since we have here vertex A, we will have the first vertex, vertex A. Since the vertex is a point, so that means we can just write the letter, the capital letter of that point, vertex A. We also have vertex B, vertex C, D, and E. This polygon has 5 vertices. Now, let's proceed to sides. Since sides are line segments, that means the symbol for side is this one. So, for example, we have side BC. Another one, side CD. Side DE. Side DE. Side EA. And side AB. So these are the 5 sides of this polygon. We name sides by its points. We use the points BC, so side BC, side CD, side DE, and so on. Now, how about angles? Since there are 5 vertices and there are 5 sides, that also means there are 5 angles. The symbol for angle is this one. So we can have angle A, angle B, angle C, angle D, and angle E. So these are the names of the parts of this polygon. Okay, now let's determine how to find the number of diagonals in a polygon. But first, what is a diagonal? A diagonal is a line segment that connects 2 vertices of a polygon that are not adjacent or consecutive. Examples of diagonals are these. In a triangle with 3 sides, there are 0 diagonals. It's because if we will choose this vertex, we cannot find one vertex that is not adjacent to this vertex. So we cannot draw a diagonal. For quadrilateral, there are 2 diagonals. 1, 2. For pentagon, there are 5 diagonals. 1, 2, 3, 4, and then 5. For hexagon, there are 9 diagonals. Now, how about a 20-sided polygon? How many diagonals does it have? How about a 9-sided or a 10-sided polygon? How many diagonals does it have? Now, to find the number of diagonals, there is a formula to be used. And this is the formula. Number of diagonals is equal to the number of sides over 2 times the difference of sides and 3. Let's use this formula to find the number of diagonals in a polygon. Let's have examples. How many diagonals can be drawn in a polygon of 8 sides? Okay, first step, we need to copy the formula, which is number of diagonals is equal to number of sides over 2 times the quantity of sides minus 3. Now, copy number of diagonals equals the number of sides. The given number of sides is 8. So we will substitute 8 to the formula. So this will become 8 over 2 times the quantity 8 minus 3. Now, let's simplify. You copy first. Number of diagonals equals 8 over 2 or 8 divided by 2 is 4 times 8 minus 3. The answer is 5. Now let's multiply 4 times 5. The answer is 20. So that means the number of diagonals an 8-sided polygon has or an octagon has is 20. Let's have another example. How many diagonals can be drawn in a polygon of 9 sides? So again, we will copy the formula. Number of diagonals is equal to s over 2 times the quantity of s minus 3. Okay, next, we copy number of diagonals equals the value of s is 9 over 2 times 9 minus 3. Now, let's simplify. You copy number of diagonals equals 9 divided by 2. Since we cannot divide 9 by 2 with a whole number answer, we will copy it first, 9 over 2, and let's simplify 9 minus 3. 9 minus 3 is 6. Now, we have a fraction multiplied to a whole number. To multiply these two numbers, we need to put 1 in the denominator. So you copy again, number of diagonals equals, okay, to multiply fractions, multiply numerator and numerator. 9 times 6 is 54. Denominator times denominator, 2 times 1 is 2. Now, let's divide. 54 divided by 2. 54 divided by 2 is 27. So that means a 9-sided polygon has 27 diagonals, or a nonagon has 27 diagonals. Now, let's find the sum of the interior angles of a polygon. Same with the number of diagonals that has a formula to be used, sum of the interior angles of a polygon also has a formula. This is the formula. Big S for sum equals n for the number of sides minus 2 times 180 degrees. Okay, let's use this formula in solving for the sum of the interior angles of the given polygons. First, what is the sum of the interior angles of an 8-sided polygon? First, we copy the formula big S for sum. Sum is equal to number of sides minus 2 times 180 degrees. Do not forget the unit, which is degree. Copy S. The number of sides is 8. So this is 8 minus 2 times 180 degrees. Now, what is 8 minus 2? Let's answer. Copy S equals 8 minus 2 is 6 times 180 degrees. If we are going to multiply 6 times 180, the answer is 1080 degrees. So that means the sum of the interior angles of an 8-sided polygon is 1080 degrees. Now let's have another example. What is the sum of the interior angles of a 6-sided polygon? So first, we copy the formula. Sum is equal to the number of sides minus 2 times 180 degrees. Copy S. The number of sides is 6. So 6 minus 2 times 180 degrees. Now, let's simplify. 6 minus 2 is 4. 4 times 180 degrees. The answer is 720 degrees. So that means the sum of the interior angles of a hexagon is 720 degrees. That's all for today, my math learners. I hope you have learned something about this video. Always remember, the only way to learn mathematics is to do mathematics.